When we stopped last time, we were doing undetermined coefficients. And we have 2 questions left. And recall, for undetermined coefficients, first thing we have to do is find the complementary function, right? And that is the solution to the homogeneous part. We already solved that one. That should have been the example we last did. It's just a different function that it equals now. Now for the particular solution. So what's the form? Third-degree polynomial. Means our particular solution has to be a third-degree polynomial. And obviously that means we have to find A, B, C, and D. Oh, that's going to be fun. What's the first derivative? Again, technically I should be doing this. G dot. We don't have to go to the second. So what's the first derivative?
(3at squared plus 2bt plus c).
And then second derivative.
Plus 2.
Now I have to plug that back into the original equation. What? Y double dot. Minus 6 times y dot. Plus 25 times y. You group all your like terms together. That's what you should get, right? And that has to equal 50t cubed minus 36t squared minus 63t plus 18. Which gives us a system of 4 equations. (25a) has to equal what?
50.
Negative 18a plus 25b has to equal what? What is it?
Minus 13.
And 6a minus 12b plus 25c has to equal what? And then finally, 2b, okay. And then 2b minus 6c plus 25b, what does that have to equal? This is actually not that difficult to solve. Right away, you should get a is 2, right? And what should b be?
0.
And what's c?
Negative 3.
And what's d? So the particular solution is just 2t cubed minus 3t. General solution, complementary function. Plus particular. And that is the general solution. Good. It's making a break for it. First thing we have to do, find the complementary. What's the auxiliary?
2.
I wouldn't use Y.
R.
R, I think is what the textbook uses.
And then minus 6R squared. Plus 1 minus 6 equals 2. I guess it was 0.
Just equals 0 for the auxiliary. And so remember, when you're solving for the complementary, you're looking at the homogeneous component. Can we easily factor that? I don't think you can. Oh, isn't that a bummer? So if I told you I had to do this by hand, you'd have to go through the pre-calculus method. We're already in July. It's ridiculous. R cubed minus 6R squared plus 11R minus 6 equals 0. Solve it for R. Table form. 1, 2, 3. What is the complementary function then?
C1 e to x2 plus C2 e to 2x plus C3 e to the 2x.
There's complementary. Now comes particular. So the equation or the expression equals 2x e to the negative x. What's the form? It's an exponential times a linear. That means our particular solution has to have the form of the exponential times a linear. I'm going to rewrite that. Because we need to go up to the third derivative. So we're going to need y prime, then double prime, and finally triple prime. Oh, well, that b e to the negative x isn't that bad. But notice what that first term is going to involve. And it's going to involve particle. I got time for that. Bigger three derivatives. Put that in there. That's going to have to now be plugged back into the original equation. I'm actually curious if I can just do this. Not let me do that. That's a bummer. Oh, wait a minute. Bummer, it doesn't let me do that. That's annoying. I tried. I'll let you do the algebra. That's what you should get. And that would be a general solution. Any questions there? A lot of algebra involved. It's definitely not my preferred method. Especially if you're using technology. Variational parameters, in my opinion, is way better. If you're using technology. If you're not, you have to do everything by hand, this would definitely be preferred. You'll see why. So get into your groups. There it is. I think Ender is numerical driven. Usually if there's an and in front of it, it means numerical.
So I'm trying to see those complex. What's that?
Yeah.
Pretty much.
At least you have a group mate this time.
I've been with,
Exactly.
1:50 will be the break, which is less than half an hour, but I'm still gonna have that tick down. 2 o'clock is when we start variation parameters. Next up, variation parameters. So if you remember undetermined coefficients, your g of x had to be of a particular form. Right? Polynomial, exponential, trig, or products, sums of them. And for the trig, it had to be sine or cosine, nothing else. What happens when g of x is tangent? You can't use undetermined coefficients. We use variation parameters. Variation parameters can also be used when your g of x is one of the forms for undetermined coefficients. And in terms of coding, it's definitely more efficient. these variation parameters. All right, so again, you can read through the motivation. All this is just like theory of the derivation. Right, the idea for second order is we want to find two functions, u1 and u2, where your particular solution is u1, y1 plus u2, y2. So we go through all this work. There's a lot of algebra. This is where you need linear algebra. Kramer's rule is going to give us u1 prime and u2 prime as w1 over w and w2 over w, where w is the Wronskian of y1 and y2. w1 is the Wronskian found by replacing, or wi is Wronskian found by replacing 0 f of x in your matrix for the ith column. Right, so w1 would be 0, should be, did I have it as f of x? Oh yeah, right here, f of x. Yeah. 0 f of x, w1 would be 0 f of x and then y2 prime, right? And then w2 would be y1 prime 0 f of x. That determinant. Which means that you just integrate these to get your u1 and your u2. And this can be extended to higher order, right? So if it's third order, you're going to have a u3, right? You have a u1, u2, u3. And they're the same. u3 would then just be w3 over w. Right? But your vector now would be 0, 0 fx. You replace each column, right? Because now it's each column would be y, y prime, y double prime. And that is variation of parameters, which means this requires linear algebra. Because you have to be able to take determinants. Doing it by hand gets extremely messy. I'm not sure if I even want to do any of them by hand. Let's see. Okay. Now that was just to find the particular solution. Then it's the same as undetermined coefficients. You have your complementary plus your particular determinant. And the complementary is still the solution of homogeneous. So general solution for y triple prime plus y prime equals secant of x. Step one is always to find your complementary function. First, auxiliary equation, right? We now spent 2 classes, normal classes, solving complementary or solving homogeneous. What's the auxiliary equation for this differential equation? This one is a very simple solve. I've got an r times r squared plus 1 is 0. So what are the roots?
Zero. Plus minus negative 5.
Plus or minus I.
You're not technically incorrect, plus or minus the negative I. We just never say that. Plus or minus I. Because it's r squared plus 1, not r squared minus 1. What is that complementary function then?
C e to the 0,
Which is what?
just C plus C2 e to the negative I,
You're not incorrect.
e to the
But we want a real valued function, not complex value.
cosine x,
Just be cosine x.
C3 sine x.
Now explain how you got cosine and sine. Why is it cosine of x and sine of x? Anyone?
What's the form for complex roots?
What's the form?
E to the alpha x.
What's alpha?
Well, in this case, it's 0.
In general, what's alpha?
Like the constant in front of it.
That has a particular name. The real component. And then you have what after e to the alpha x?
C1 cosine the complex component.
Beta x, right?
Beta x.
Yeah, where beta is your imaginary component.
The imaginary. Plus C2 sine it.
Yeah, it's the same thing, right? Then just be e to the alpha x sine beta x.
Yeah.
Real component here is 0. Imaginary component is 1. I'm going to do an additional step here. And actually write out the 3 independent solutions. Because you do need those for this technique. What's y1?
C1. 0. Is it 1?
It's just 1. What's y2?
Cosine x,
What's y3?
sine x.
Those are your 3 independent solutions. Now for the particular. I'm using G instead of F. Doesn't matter. You need all those. Because what we have to do now is find W, W1, W2, and W3. Start with just W.
That's the 1.
First column is Y1, Y1 prime, which is what?
Yeah.
And Y1 double prime, which is what?
Yeah.
There's your first column for the Wronskian. Second column is Y2. Probably need to move this down. Now Y2 prime. and y2 double prime. y3, y3 prime, and y3 double prime. That determinant. Cofactor expansion makes this extremely easy. Just expand along the first column. You get 2 zeros. The Wronskian should be 1. It is. Right, it's 1 times sine squared plus cosine squared. I don't think we can go through all the calculations for W1, W2, and W3. All right, but W1, what you do is replace this column, 0, 0, secant of x. Now take the determinant. Again, that's not too difficult to do with cofactor expansion along the first column. You'll get 2 zeros. So it'd be what? This is 3, 1 positive. It would be secant of x times that determinant, which is also 1, by the way, so that would be secant of x. W2, you now replace this column with 0, 0, secant of x. Take its determinant. Column 3, replace this, or W3, replace this with 0, 0, secant of x. Take the determinant. I'm going to do this, and I'm going to have to make an adjustment now in my code, which is annoying. So I've already wrote the outline of the code. By the way, for those of you unfamiliar, this just indicates the comment, not part of code. Much like you can leave comments in any coding language. Alright, so I've already had it set up. You have to define your y1, y2, y3, g. Then I defined w, w1, w2, w3 as the appropriate determinants. Defined u1, u2, u3 to be the integrals of their primes, right? So it's just the integral of w1 over w, w2 over w, w3 over w. And I have it set up to print everything. What is w, w1, w2, w3, u1, u2, u3, and then the particular solution. All I have to do now is execute it. But there's going to be a problem. Uh-oh. Hasn't been closing. What are you talking about? Hasn't been closing. Oh. Stuff will simplify there. Let me fix that up here too. You're not giving me the new lines that should be giving me. Okay, so the web version isn't giving you those extra line spaces. I know the desktop version does because that's what I use there on notes. I think what I'd have to do is probably do this. Not even that didn't work, so it's not going to give me those extra lines. Which is truly annoying, but whatever. Okay, yeah, so two errors occurred. Two problems occurred. First, look at W. Look what it says W is. Cosine squared plus sine squared. That's not simplified. Wolfram doesn't generally fully simplify unless you tell it to. So I have to add full simplify to all of my W's. The second issue, look at U1. Uses hyperbolic functions. That's not incorrect, you can use them. But if you haven't studied hyperbolic functions, you have no idea what the hell that is. There is a way around each of those. So first I'm going to add not there. No, add here. By adding full simplify, all of these, it should give me nicer forms.
Is there a way to make it overall variables? So you don't have to go through each time and change it?
You can define functions.
Yeah.
So you can define your own functions in Mathematica. I generally don't. And when I say functions, really what you want to do is, if it's going to be a function, you want it as its own specific command. So if you have like a really complicated command, you store it. And then recall it later, you can. For here, it's not really worth it. That looks better, right?
Is that natural log?
Yes. And Wolfram LOG is natural. Now, what we can do to get rid of those hyperbolics, and I don't include this because you're not always going to get the hyperbolics, you want to go trig to exponential. So I'm just going to do it for where am I? U1, let's say. No, that's it, yes. Leave that in my notes.
You just full simplify again.
I don't think it's trig to exponential, I think it's trig to So I actually don't want exponential, pure exponential. Takes me back to trig. I'll give this to me in my notes. Oh dear, no. So who's W1? Secant, right? Okay, so I don't know what's going on. They changed it since last time I used this. Just give what it should be. Here's what we should get. But I also didn't get secant W1. I certainly feel something. My notes give me W1 is cosine plus sine times tangent, which is not secant. So once I screwed up,
does fully simplify what we see.
Yeah, okay. U1 should be this. I'm gonna use absolute values too. My notes, when I ran this, did it for me. It didn't give me the hyperbolic. So that might be a new change with one of the updates for Wolfram. U2 negative x, and U3 is log of cosine. But you're not incorrect if you use the hyperbolics. Yp is U1 times Y1. Plus U2 times Y2. U2 is cosine, right? Plus U3 times Y3. That's your particular solution. And then your general solution is the sum of the two. Right, your complementary plus your particular. No idea. I'll figure it out. This one shouldn't give us much of a problem. First complementary. Which means we need the auxiliary equation. Which is what?
RP minus 3 R squared. R equals 0.
Again, this shouldn't be too difficult to solve. R squared minus 3R plus 2, can that be factored? What is it factored to?
Negative 3 or sorry, positive 3 or negative 1.
-1, -2.
And there are your three solutions. Three roots, right? What's the complementary? C1, C2 e to the x, and then C3 e to 2x. Right. For the particular solution, y1 was what? What's y1?
1.
What's y2? And what's y3?
2x.
What's g?
0. E to the x over 1 plus e to the negative.
That ugly looking thing. Now for W, it's not too bad. Even finding W1, W2, W3 shouldn't be that terrible. But now you have to integrate. That might be a little hideous to do by hand. It is doable, right? Just probably not going to be too fun. So this one shouldn't give any problems. Get rid of this though. That, so I should do this now. One, it was then what, e to the x? And two ways you can do e, I think I don't remember if I showed this. Actually, three ways. exp to the exp of x, that means it's the exponential function. You could also do capital E. Capital E represents the natural number. Or escape E escape sets up that. You might even be able to do / exponential E, close out the bracket. Oh, actually, I have to spell it out. Oh dear. I don't know if you can see. Yeah, it does come up. Right, it's this one here. As your command. Which will then give you that, and then raise to the power. I'm going to stick with my favorite. Oh, lovely, it's giving me the inverse hyperbolics again. But this one I should easily be able to write into exponential form. Which one gives me the inverse? U3 gives it to me, which means that's going to give it to me as well. Let me just see what would happen if I do trig to exponential. Yeah, there you go. This one works out nicely. Last one wasn't because it was writing that sign, also in exponential form, which is a complex valued function. So I have to somehow word it so that's only converting the inverse hyperbolic and not the actual sign itself. So that's how you get around the inverse hyperbolics. Right, so what I would do is I'd probably in here, now that I see the output, I'd probably right here, if it doesn't keep doing that. Just add it in and then re-execute instead of changing my entire code. Or what would happen if I switch these? That first and then do full simplify. It's going to put me back. We have box. It's actually irritating. So I'll just go back to here. Say there you go. What's happening? Oh, okay, I simplified with my notes. I think what I'll do is I'll just copy this. Copy as an image. There's the particular solution. Oh, you can't see that. Okay, there's the particular solution, along with all the W's and the U's. And then do this. So we're gonna have the 3/2 e to the x. E to the x over 2. What kind of particular solution? Let's combine. Those using laws of logarithms. So e to the 2x log square root negative 2e to the x over 2 plus 2e to the x. Absolute value. That, right? Because it should all be in absolute values. And then just that minus 3/2. I'm gonna write it this way, minus 3 log square root of 1 plus e to the x. And actually, that's not fully simplified. I think I will do that too. You can also get rid of those 2's. That's nice. Because I can actually get rid of that absolute value now, can't I? Just make it 1 over 1 plus e to the x. Because 1 plus e to the x will always be positive. And write it that way. And then just make a note, C4, C2 plus 3/2.
Are we expected to simplify, or is it fine if we leave it?
Honestly, I'd be happy if we got up to that. But in more advanced courses, they probably want to simplify. Maybe not this one here. Right, but they definitely want you to combine your e to the x, because it's just the sum of 2 constants. And that is a very common tactic in mathematics, where you just combine a bunch of constants and define a new constant. These particular solutions look a lot worse than the undetermined coefficients, right? And generally speaking, that's what's going to happen. The solutions will be a lot more hideous. So here, yeah, there is going to be difficulty if you're doing it by hand. You're going to have to calculate the determinants, which is a pain. And then you get to do really ugly integrals. If you just look here, what was W? This here? And that's W1. W1 over W. Integrate that. Because that's U1, right? Because U1 prime is W1 over W. Which means U1's that integral. That's an ugly integral to do by hand. But it's definitely way better when you can code it. Which is what I would recommend you do. Use a calculator to do all that math for you. And then just be careful when you're copying. Make sure you put it in right and you're copying it right. And so maybe if you want to show your work, just show what the matrix is you're taking the determinant of, like we did here, and then what it equals, and don't do it by hand. And show what the integral is, what you're integrating, and then use the calculator to actually tell me what it is. Don't try and do it by hand. Just imagine how long that would take you to do it if you're doing it all by hand. And that's only third order. That's not even like an eighth order. Oh, there. Thankfully, that's only second order. That's going to be better. And again, what you want to do is generally look at what it equals and go, can I use undetermined coefficients? If not, then you have to use variation parameters. How big is this going to turn out to be? Doesn't look like this would be too bad to do by hand. So let's try and do this one by hand. What's our auxiliary equation? Which factors? What's the complementary function then?
C1 e to the x plus C2 x e to the x.
C1 e to the x plus C2 x e to the x. And this is where we're going to have to use variation parameters. Y1 was e to the x, y2 x e to the x, and g of x is e to the x over x. Now, derivative of x e to the x is just e to the x times x plus 1. Wronskian should just be e to the 2x. And W1, just replace the first column with 0 e to the x over x. Oh. Negative e to the 2x. Right. 0 minus x e to the x times e to the x over x. And W2, is just e to the 2x over x. And so this one I'll do by hand because it's not that difficult to do, just to show you the actual process without a calculator. U1 prime, W1 over W, just get negative 1, right? U2 prime is W2 over W. Just 1 over x. You should easily see what the anti-derivatives are, right? U1 is negative x. U2 is natural log absolute value of x. Your particular solution, U1 times Y1 plus U2 times Y2. And our general solution, which can be simplified. You can read that, right? C3. C3 is C2 minus 1. So why is that one off balance? Something weird happened there. Yeah, I don't know what's going on with that slide. Somehow I think it's, yeah, it can't be bothered to fix it. it, so I'll just leave it like that. I think this should refer back to normal here. So notice here, you can actually use undetermined coefficients. And for the sake of time, complementary, you're going to get C1 e to the negative x plus C2 e to the 2x. I'm just going to plug this into the code I already have for variation of parameters for second order. And your challenge will be to confirm that undetermined coefficients gives you the same thing. That's fair. Okay, so that explains it. Just type in my code. That should not have been a plus. That should have been a times. That's going to change that particular solution. Which means this one's also wrong up here. That should be times. Although I don't think that's going to adjust anything. Yeah, it doesn't really change much. I'm going to fix it up here. Because this code will be uploaded. That's better. Okay, so that's what you should get as your particular solution. Even 3x over 4. Sure, I can put that in the second order as well. And then obviously your solution is just C1 e to the negative x plus c2 e to the 2x plus 1/4 e to the 3x, which you should get from undetermined coefficients as well. In fact, we may have actually done that problem. This one, yeah. This one's fine. First complementary. Should get r squared plus 4 is 0, right? No, that's easy. Plus minus 2i. T. It shouldn't be y, right? It should be x. There's the complementary function. X1, cosine of 2t, x2 is sine of 2t. G of t is sine squared of 2t. You cannot, I don't think you can use undetermined coefficients on this one. This is a sine squared. If it was just sine, you'd be fine. Sine squared, I don't think you can be able to do. So a variation of parameters. Here. So I'm just going to plug it into the code that I already have. But what we're going to do is treat them as like y of x's instead of x of t's, and then adjust for that later. Because I don't feel like rewriting it. I don't think you need the parentheses. I'm just going to put them there to be safe. And that should be the particular solution. Not what I got. Oh, because I probably because I didn't fully simplify. That's 2, that's correct. Sine cubed, cosine times sine squared, yes. This is where things differ, I believe. -4. All right, that's negative. Yeah, I think the reason is I just didn't fully simplify my solutions in my notes. So that was right. That'd be a particular solution, right? And then complementary plus particular. That is the variations of parameters. Questions on that? And again, I would recommend using a calculator to do the linear algebra and calculus for you. Save yourself that headache. Here's a challenge for you. You can use undetermined coefficients to solve that, right? So that's not like a challenge. That's actually pretty easy with undetermined coefficients. Your challenge is to take the code, adjust it for fourth order, and use variation parameters. That would be your challenge, see if you can do it. If you want to do it by hand, go ahead. Again, I don't think it's actually that difficult to do by hand with variation parameters. Let's see if you can adjust the code. Because I gave you second order and third order code. So adjust that for fourth order. Again, the code will be up there after class, I'll upload it. And then do undetermined coefficients and verify you get the same thing. Here's how next class is going to work. We'll start with the variation parameters worksheet. 10-minute break, or actually it'll be a 5-minute break. So it'll be 30 minutes, 5-minute break. Then we move on to the next topic, which is what? No, fun. Physics. Second order models. And so 3 types of problems: the spring problem, RLC circuits, and central force. Although I think my examples don't involve the central force. I think it's just RLC and springs. And there'll be a worksheet for that as well, so 2 worksheets next class. I was going to take the special note. Oh yeah, Third quiz will be available after next class as well. And it goes up through physics. I'll see you then. As soon as I put that outside. Yeah, that'll post this Wednesday.
I didn't